There's a $3 clay pot sitting in the garden section of every hardware store in America. It filters bacteria out of water more effectively than systems that cost $300. Not with expensive cartridges that need replacing every 3 months. Not with UV lights that stop working when the power goes out. It uses microscopic pores baked into the clay itself. No electricity required, no replacement parts needed, no experience necessary. This technology has existed since ancient Mesopotamia, when potters along the Euphrates River discovered it around 2000 BCE. Egyptian households used it for centuries. Indian villages passed it down for generations. Then the water filtration industry figured out something devastating. If homeowners discovered this clay pot, they would never buy another filter cartridge again. A $3 solution that replaces a $300 system cannot be allowed to spread. So they buried it, not because it failed, but because it worked too well. This is the story of the water filter the modern industry prayed you would never find. Let me take you back to where this technology was born. Around 2000 BCE, potters in ancient Mesopotamia noticed something strange. Water stored in unglazed terracotta pots made fewer people sick than water stored in glazed or metal containers. They had no germ theory and no microscopes. But they observed the pattern clearly enough to standardize it. The Egyptians refined the technology along the banks of the Nile River. They developed the zir pot, an unglazed terracotta vessel that both filtered and cooled water through evaporation. Archaeologists have recovered zir pots from Egyptian tombs, still structurally intact after 3,500 years. In India, the technology evolved into the matka. A 2010 study by the Indian Institute of Technology found that villages using traditional matka pots had 60% lower rates of waterborne illness than villages using modern plastic containers. It was not because the clay added anything, but because it removed what was killing them. For 4 millennia, this was humanity's primary water purification method. No patents, no brands, no subscription fees, just fired clay and gravity. Then in the 1970s, the home water filtration industry emerged with proprietary cartridge designs. Brita launched in 1966. PUR entered the American market in 1986. The industry did not grow because the new products were better. They grew because the new products generated repeat revenue and the old solution quietly disappeared. Today, the global water filtration market generates $45 billion annually. A $3 clay pot that lasts for years is a direct threat to that entire business model, so the knowledge was buried one generation at a time. Here's what happens at the microscopic level when water passes through unglazed terracotta. Clay is composed of aluminum silicate particles fused together through high-temperature firing. When the kiln reaches 1,000 degrees Celsius, those particles bond into a matrix filled with microscopic channels called micropores, ranging from 0.5 to 3 microns in diameter. Water molecules pass through these pores effortlessly, but E. coli bacteria measure 2 microns. Giardia cysts measure 8 to 14 microns. Cryptosporidium ranges from 4 to 6 microns. Every single one of these pathogens is physically too large to pass through. They slam into solid clay and stay behind. A 2017 study in the International Journal of Environmental Research tested terracotta filtration against E. coli. The unglazed clay achieved a 99.88% removal rate. Researchers at MIT confirmed similar results in field conditions. The $300 countertop filter uses the exact same principle: microporous ceramic filtration. The only difference is the plastic housing and the proprietary cartridge designed to need replacement. The markup is not on technology. The markup is on your ignorance. Now, I need to be honest with you because this technology can save your life or destroy it. The difference is knowledge. Not every terracotta pot is safe for water filtration. Some clay pots contain lead. Lead glazes were standard in pottery manufacturing for centuries. In 2015, the FDA issued warnings after imported ceramic cookware was found leaching lead at levels 10 to 100 times above safety thresholds. Lead causes irreversible neurological damage, especially in children. The pot must be completely unglazed. If it has any shiny coating, any smooth sealed surface, any decorative finish, do not use it. Period. Second warning, some terracotta pots sold for gardening are treated with fungicides or copper-based pesticides. These chemicals are designed to leach into soil. Pour drinking water through that pot, and you're consuming whatever they soaked into the clay. You need food-grade, untreated, unglazed terracotta. Contact the manufacturer directly. If they cannot confirm the clay is food safe, do not risk it. Third warning, this is the one most DIY videos ignore. Clay filtration does not remove viruses. Hepatitis A virus measures 27 nanometers. Norovirus measures 23 to 40 nanometers. The micropores in terracotta are 500 to 3,000 nanometers wide. Viruses pass straight through. Clay filtration also does not remove dissolved chemicals, pesticides, heavy metals, pharmaceutical residues. If it is dissolved at the molecular level, it is passing through. This is not a magic solution. This is one stage of a multi-stage system. Here is exactly how to build a complete water purification system that works. Stage 1. The terracotta filter. Acquire an unglazed, untreated, food-grade terracotta pot from any garden center. Standard 6-inch pots cost $2 to $4. Seal the drainage hole at the bottom using food-grade silicone and let it cure for 24 hours. Position the sealed pot over a food-safe collection container. Pour contaminated water into the pot. The water will seep through the porous walls, typically 1 to 3 liters per hour. That's stage 1 complete. You have removed bacteria, parasites, sediment, and turbidity. Stage 2. Chemical removal. The filtered water now passes through activated charcoal. 1 gram of activated charcoal has a surface area of 3,000 square meters. Dissolved chemicals, chlorine, and pesticides bond to this surface through adsorption. Buy activated charcoal at pet stores or aquarium shops for approximately $10 per pound. A pound lasts months. Place charcoal in a secondary container or directly inside the terracotta pot above the waterline. Stage 3. Viral disinfection. 2 options. Option A. Bring the filtered water to a rolling boil for 1 minute. At elevations above 6,500 feet, boil for 3 minutes. Option B. Add unscented household bleach, 2 drops per liter of clear water, 4 drops per liter if the water is cloudy. Let stand 30 minutes before drinking. That's it. 3 stages: physical filtration, chemical adsorption, viral disinfection. Total cost under $20. Ongoing cost nearly $0. A commercial 3-stage system runs $200 to $400 up front, plus $50 to $100 annually in replacement parts. You just built the same system for the cost of a fast food lunch. This system requires maintenance. Every 2 to 4 weeks, scrub the terracotta pot with a stiff brush and clean water. No soap. Soap clogs the micropores. Every 3 months, heat sterilize the pot in an oven at 200 degrees Fahrenheit for 1 hour. Critical warning about freezing. If this pot freezes with water inside, the expanding ice creates micro-fractures in the clay. Bacteria pass through fractured clay. If your pot has ever frozen, replace it immediately. Walk into the water filtration aisle of any home improvement store. You'll see $40 pitcher filters with cartridges that expire after 40 gallons. You'll see $300 under-sink systems with proprietary fittings. You'll see $600 whole house units requiring professional installation. What you won't see is a $3 clay pot. The global water treatment market will reach $105 billion by 2030.
That projection depends on consumers believing they cannot purify water themselves. The moment you learn this system, you exit their revenue model permanently. When the grid goes down, your UV filter becomes decoration. When supply chains collapse, your replacement cartridges stop arriving. A terracotta pot requires nothing. It works the same today as it did 4,000 years ago. That's why this knowledge was buried. Not because it stopped working, because it works so well that an entire industry cannot survive if you remember it. The Egyptians knew this. Your great-great-grandparents probably knew it too. It was common knowledge, written in the margins of old farming manuals, demonstrated in workshops across every civilization that understood clay. Then one generation stopped passing it down because a television commercial told them there was a better way. There wasn't a better way. There was just a more expensive way.